we take a look at sample problem 10.12 from your text. You're welcome to look at your text or play and rewind this as we learn how to do it. First thing we want to do with empirical formula and we're given percentages is assume that we have 100 grams total of the substance in question. Because when we do that, our 25.9% nitrogen conveniently becomes 25.9 grams of nitrogen. In similar fashion, our 74.1% oxygen becomes 74.1 grams of oxygen. Notice we went O and not O2 because this is a compound, and we are going to find its formula of the compound that we have. So we know formulas and compounds talk to us in moles. So now next thing we're going to do is make a couple gram to mole conversions. So with our 25.9 grams of nitrogen, we're going to go ahead and find the molar mass of nitrogen off the periodic table, which is 14.01 grams per mole. And so we're going to grams of N in 1 mole of N. And we're going to go ahead and use our calculator to figure out how many moles of N we actually have. We're going to divide by 14. Do everything to 2 decimals. So we have 1.85 moles of N. We're going to do a similar problem with our oxygen. We're going to convert from grams of oxygen into moles of oxygen. And from the periodic table, there are 16.00 We're going to go ahead and go with it, guys. My computer kicked off there. We have 16.00 grams of O in 1 mole of O. And we go ahead and punch that into our calculator. And we get 4.63 moles of O. So these are the representative amounts of N and O. And in theory, I guess we could do something like this. N with its 1.85 moles and O with its 4.63 moles. But we never ever see a formula written like that. Formulas are always written in simple whole number ratios. So what we're going to do here is we're going to take the smaller of those 2 mole numbers, in this case the 1.85, and we're going to go ahead and divide both molar amounts by 1.85. So when I take my 1.85 moles of N and divide it by 1.85, come up with 1. I do a similar problem with my 4.63 moles of O. Go ahead and do that. Here's my 4.63 again. Notice I get 2.50. So we are closer, but not quite totally correct. So now with our 1 mole of N and 2.50 moles of O, you would think we'd be inclined to write a formula that looks like this. N sub 1, O sub 2.5. But yet again, that never works because we never put non-whole numbers in our formula. But looking at what we have here, we can take our 1 and our 2.5, and we can go ahead and multiply our 1 by 2 to get 2, and our 2.5 by 2 to get 5. And so our empirical formula for a compound that contains 25.9 grams of N and 74.1 grams of O becomes N2O5. If we wanted to name this compound, it's a molecular compound, so we would call it dinitrogen, and the prefix for 5 is pent. So we just made dinitrogen pentoxide. And again, this is taking percentages and using those percentages to calculate an empirical formula. Apologies for the blackout in the middle. These will improve as time goes along.